Hello, everybody. Can you hear me?
Yes.
Thank you. I'm going to make a request, and that is that I'd like, but I can't enforce it because I haven't put it in the syllabus, but I'd really like you to show your video, please. If you're choosing not to, then I suppose I'm just going to deal with that. Okay. All right, thank you. I'm not sure who's Jallery ES. Oh, okay, that's are you in the, but you're in the course that just started, Jallery, is that right?
Okay, sorry. Jalary.
Jallery, I'm sorry. Are you in the express course?
Yes.
Yeah, my session's actually for you is at noon.
Oh, okay.
I think I got that in the syllabus. I know you probably saw it online, but that's the yeah. But I've got one at 11 that's dealing with module 5. That's for the course that started in January. But I'll be with you at noon. Okay.
Okay, no problem.
All right. Okay. So let's go ahead now and we'll start going through module 5. Now, what I'm going to do is I'm going to do a little bit of background first, sort of give you the nuts and bolts of what you need here. So we're dealing with specifically 4 kinds of things, 2 kinds of cations and 2 kinds of anions. So we'll talk about the cations first. The cations, we've got the type 1s, which everything in group 1, group 2, and aluminum. There are also some others, zinc, cadmium, silver, bismuth. You won't have to worry about these too much because I haven't actually included any of those in the quiz. But these are all considered to be type 1s as well. And what makes type 1 special is that the charge is already known. So 1 plus, let me move this over here a bit. 2 plus and aluminum is 3 plus. So we already know what these charges are. These charges are set. And the consequence of this is that since we know the charge, it doesn't have to be included in the name. And you'll see that when we do the naming here. For type 2, okay, and I'll also, well, let me get rid of that and I'll write that down as well. No Roman numerals in name. Okay, type 2. That's pretty much everything else, all other metals. Charge, maybe 2 or more different charges possible. And then we've got the anions, and we've got single element, which are things like Cl, S, and O, etc. And then you've got the polyatomics, which, as the name suggests, includes more than one ion, like SO4. Let me put some charges on these. ClO3 minus. So those are, yeah, those contain more than one element. Does anybody have any questions so far? So let's take a look at the Module 5 soft chalk here, and I go through all of this in the Module 5 soft chalk, but that's just a summary of what we're seeing here. So I've got the charges here on each of these. So in the single element anions, the charges are set by the group. So -1 will be group 7, -2 will be group 6, and -3 will be group 5. And these are the electrons required in order to get it to the octet. So 7 plus 1 is 8, 6 plus 2 is 8, and 5 plus 3 is 8. Okay. I'm going to leave these rules over here, and I'm going to open another instance of this chalkboard here. If I can. Yeah. All right. And I wanted to go through a few examples just to illustrate what I was talking about. So let's see. We'll do all right, so and see how we handle the names here. Now, if we're talking about the type 1 cations, the charges are set. We don't have any Roman numerals in the name. Type 2, we do put Roman numerals in the name. So Roman numerals show charge. And then we've got, so we can go ahead and do this for calcium. So Ca3N2. So that'd be calcium. And then the single element here is nitride. So all of these single elements end in IDE. So nitrogen becomes nitride. You'll notice that there's no Roman numeral here because calcium is in group 2 and has a charge of 2 plus. Now, how do I know that? Sorry, I'm just checking who's here. Okay. Let's go back to the previous page here. Calcium is in group 2. It has a 2 plus charge. And nitrogen has a -3 charge. That doesn't really have any real meaning here. But you'll notice that that's how we set up the name. Does anybody have any questions about this one? Now you might be wondering, well, why don't we need to know how many of each there are? Well, it's because if we drew a picture, this is what the picture would look like. There'd be 3 CAs and 2 Ns. We already know what the charge on the calciums is. It's 2 plus on each of them, which would be plus 6. Nitrogen is 3 negative on each of them, so that's negative 6, so it balances out. This is why I don't need to say how many of each there are in the compound, because we know from the charges how many there have to be in order to make the plus 6 and the minus 6 balance out. Does anybody have any questions? I think that's an important point. Okay. Now the next one, Cu3N. If you look where copper is in here, so it's one of the type 2 cations, and we need to be able to know what charge it has. And in order to do that, we have to do a little bit of algebra, because we need a Roman numeral here. So N has a 3 negative charge, which means the total charge here is negative 3. That means the total positive charge has to be plus 3 to match it. And then each of these would have to be positive 1. So this would be copper, and then we need the Roman numeral 1 nitride. So the 1 here represents the charge on each Cu. All right, does anybody have any questions? Nobody has any questions, huh? All right. Now with CaCO3, I include this one because I want to make a point about polyatomic ions and how many there are. See, if I've got CO3 here, CaCO3, what that would be as a picture would be 1 Ca and 1 CO3. There aren't 3 COs here. If there was more than one of these elements, then there would be parentheses around it and a number on the outside, and that's what I'm looking at here with the PB1. Now CO3 has a negative 2 charge, excuse me, and I know this because it's on the polyatomic ion sheet, which you're always given with any test that you're taking. And we can see from here carbonate has a negative 3 charge. Sorry, negative 2 charge, sorry. So that's Ca2 plus, because it's in group 2, CO3 2 minus, that would be calcium carbonate. Now, why is this confusing? It's because if I go back, let's look at another example. If I had FeBr3, that's a single element right there. And that would indicate there were 3 Brs. But when you've got CaCO3, there's only one of these. So it's really important to note the difference that you're seeing there between what's happening with the polyatomic ions versus what's happening with the single element anions. Does anybody have any questions? Because I think that's a really important point.
I have a question.
Yeah.
So you mentioned that we'll get the polyatomic ion sheet with our during our test.
Mm-hmm.
So will it be how we had it in test 1 where it was like above all of the questions and then we can
Yeah,
just scroll up and see it?
that's right.
Okay. Thank you.
Yes. So you won't need to print it out
Okay.
and have it in front of you. I'm not expecting you to memorize any of these.
Okay.
The reality is, though, you'll get to learn some of them because you'll see them a lot, and you won't need to look at the polyatomic ion sheet as much as you might think. Okay, the next one, and again, note with this one, the calcium is a type 1, so it's we don't put a Roman numeral in the name. Now PbSO4 that does have 2 SO4s in it, and we can see that from the 2 here. SO4 has a -2 charge according to that sheet, so that's -4, which means that the lead has to be +4 to match it. So that would be lead 4, that's a Roman numeral sulfate. So the name of SO4, as you can see from here, is sulfate, SO42- sulfate. Okay. So what are the main things to be concerned about, just summarizing? First of all, you need to know exactly when to use Roman numerals and when not to use Roman numerals. You need to be aware that the Roman numeral represents the charge on each cation present, if you do have to include it. And you also have to be aware of how to determine the number of both single element anions present and the number of polyatomic ions present in each of those separate cases. If you know those things, then you should be okay. Does anybody have any questions? Okay. Let's turn now to the naming of acids. And we have two kinds of acids that we're dealing with. Single element acids, where the anion equals Br minus, I minus, S2 minus, etc. And these are named hydro something ic acid. Hydrobromic, hydroiodic, hydrosulfuric. The hydro here does not indicate hydrogen. It indicates it's a single element anion. And we look at polyatomic acids, where the anion might be BrO3 minus, SO4 2 minus, SO3 2 minus. Let's not use those. Those are a little bit special. I'll use different ones here. We'll do NO3 minus and NO2 minus. And the names of these are going to be something ic acid if the ion ends in 8, or something us acid if the ion ends in ite. So what I'm talking about is over here, you see a bunch of these end in ate, chlorate, and some end in ite, like chlorite. And this has an effect on the name of the acid that they come from. So let's go ahead and see the effect of that. So going back to the top here, HBr, since that's a single element, that would be hydrobromic acid. For some reason, something's slowing down my computer. I'm not sure what it is exactly. And if you had HBrO3, this will be bromic acid. Now this is based on the fact that BrO3 is bromate. And then you've got HNO2, or say HNO3 will do first. That's nitric acid, that's based on nitrate. NO3 is nitrate, so that's nitric acid. And the last one, HNO2, that's based on NO2, which is nitrite. So that'd be nitrous acid. Does anybody have any questions? The acids are probably the hardest ones to name because you have to remember the difference between single element acids with the hydro out the front, and then the polyatomic acids, which have to do with what they're named. So ate goes to ic acid and ite goes to us acid. Anybody have any questions?
I have a question.
Yeah.
So, for the acids, there's always going to be the hydrogen in front of like what the rest of it is, right?
Yeah, H plus. Yeah, H plus is always the cation.
So, when we're naming the polyatomic ions, we just take the H out, and then that's where we get the name and how.
That's right. The acid part is the H plus. That's what's defining the H plus is the acid, the word acid.
Okay.
Again, the rest of it is based on the anion. That's exactly right. All right. Any other questions?
I have one more. Sorry.
Yep.
So I'm looking at one of the examples. It's HCIO.
It's CLO. That's an
CLO. Sorry. And the name is hypochlorite.
Yes.
Where did the hypo come in? Because I'm looking
it's from the name. If you look at the name of the ion here, that's what it's called. CLO minus. It's called hypochlorite.
Oh, okay. I was looking at the other side. That's why. Sorry.
That's all right. So that would be hypochlorous acid.
Okay. Thank you.
All right. You're welcome. All right. Any other questions? Okay. Lastly, we'll deal with the compounds that have two nonmetals. And what we're talking about here are compounds that contain, well, if we look at the periodic table, nonmetals are on this side of the steps. And as such, they don't form binary compounds where something has a charge on them. They tend to share electrons. So they need to be named differently. So when we did the naming previously, we were looking at charges on anions and cations. We can't do that here. So what we do is we just simply state how many of each there are in this specific compound that we're talking about. So the rules here is if there's only one unit of the first element, then mono is not used, because there's a lot of compounds that have just one unit of the first element. So if you've got something like P2S5, we just use the prefix that we're given here. And again, you're given these prefixes, you don't have to memorize them. They're on the polyatomic ion sheet. So di equals 2, penta equals 5. So this would be diphosphorus pentasulfide. CO2 would be carbon dioxide. Remember, there's no need to put mono in front of the carbon because there's only one of them. Dioxide because there's two oxygens. CO would be carbon monoxide, not monocarbon monoxide. But since there's only one of the second one, we do need to put a mono in front of that. So that's how we do the naming for two nonmetals. Anybody have any questions?
So like we only put the mono for the second element?
That's right, if there's only one of them, Isra.
Okay.
Otherwise, you just use whatever prefix you're given here. All right, I've got some other examples down here. NO would be nitrogen monoxide, N2O would be dinitrogen monoxide, NO2 would be nitrogen dioxide, N2O4 would be dinitrogen tetroxide, N2O5 would be dinitrogen pentoxide, N2O3 would be dinitrogen trioxide. Does anybody have any questions? Okay. All right. Now, going from names to formulas, I think, is a lot easier than going from formulas to names. So let's look at some examples of those. You'll notice some of the examples I include will be following the rules that I just talked about. Okay. So the way we do these is you have to figure out the charges on them. So Ca has a 2+ charge because it's in group 2, and O has a -2 charge because it's in group 6. So let's go back to the page here so we can get that. You'll notice there's nothing in the name that tells us that calcium is 2+, if you look at the name. So you have to be able to determine it by looking at the periodic table. And calcium's in group 2, which is why it's +2. Oxygen is in group 6, which is why it's -2. So that would be CaO. Just need one of each to balance the charge. The next one, copper 2 chloride. Now 2 doesn't mean there's 2 coppers. What that tells us is that's the charge on the copper. So it's Cu2 plus, and then chloride is going to be Cl1 minus. It's in group 7. Has a -1 charge. And then we have to ask ourselves the question, well, how many Cls do I need to balance out the coppers? And you can see that it would need 2, so it'd be CuCl2. Does anybody have any questions? For next one, strontium phosphate, Sr is 2 plus and PO4 is 3 minus. The Sr comes from group 2, so it has +2. And phosphate, we get off the polyatomic ion sheet. And you can see phosphate is down here at -3. And then the question becomes, well, how many of each do I need to balance this out? Well, one of each isn't going to cut it because +2 and -3 don't balance out. But if I multiply these together, I get 2 times 3 is 6, which gives me an idea of how many I'll need. So it'll be 3 SRs to give me +6 and 2 phosphates to give me -6. And that would be my final structure there. Does anybody have any questions?
I have a question about like figuring out the charges.
Yeah.
So like if it's in the transition metals section, how do we like figure out the charges and the elements?
Well, on these, it's just whatever the Roman numeral is.
No, like if it was like the other way, like trying to like make it into the name.
Oh, okay. Well, yeah. Okay. I'll go back to that in a second. Okay, Ezra. We did cover that earlier, but I will go back to it. Okay.
Okay.
So tin 2 plus and hydroxide is OH minus. So we need 2 hydroxides to balance out the tin. So it'd be SnOH2, and the OH is in parentheses. Okay. Any questions about these? Okay. Ezra, I'll go back and I'll answer your question. Let's say we had SnClO4. So what that would mean is that you'd have Sn, if you drew a picture, it'd be ClO, ClO, ClO. The charge on ClO is hypochlorite. That's going to be -1 from the chart. That's a total of -4. In order to match, this has to be +4. So tin has to be +4. So the process involves this kind of U shape that I'm showing you here, Ezra. You have to figure out the charges on the negative side, make it balance out on the positive side. That's how you know. So the name then would be tin 4, hypochlorite.
Okay, thank you.
Okay. All right, does anybody have any other questions? Well, let's look at, just making sure nobody else has popped in here. Let's take a look at something else here. We'll look at the assignment. So I've got in the directions there here that the answers are all single ions. So what that means is if I was asking you for the cation of Li2O, you'd just put one of these Li's, not both of them. And the charge on that would be Li plus, and the charge on the O would be -2. So this is sometimes confusing to people because they forget about the single ions. All right, let's look at this one. Cation of Be3N2. So what you would do is you find out the charge of Be. It's going to be 2+ because it's in group 2, but it's also 2+ because that's what balances out the 2 N3 minuses. So the cation, the answer would be Be2+, the anion would be N3 minus. And that would be the choice you would make on each of those. So you have to find the correct one here. So that would be that one for Be2+, and N3 minus, and this one down here. All right, does anybody have any questions? Any questions? All right, so that's how the assignment's going to go. So there's 100 of those questions, as you can see. Should take you about half an hour if you know what you're doing. It's going to be frustrating as heck if you don't know what you're doing, though, I'd say. And then you've got I'm going to go through the practice quiz here. All right, so these are all multiple choice. So there's not much you have to do as far as memorizing goes. But I will put this over here. Okay. So let's say we're looking at strontium nitride. You know that strontium is going to be 2+ because it's in group 2. Nitrogen is 3- because it's in group 5. So we need to figure out how many of each we would need to make this balance out. It's not going to be one each. 2+ and 3- don't balance out. If we multiply them together, though, we get 6. So we need 3 to get to 6+, 3 SRs, and then 2 Ns will get us to N6-. Any questions? You'll also notice, well, actually let me put the answer in here. Again, it was SR3N2. You'll notice that I don't think it's actually an answer here. So you have to select none of these, and none of these is actually an answer to some of these. So it'd be none of these. That's one thing I want to point out. Okay, next one, chromium 3 bromide. Cr3 plus for the chromium 3, Br negative for the bromide because it's in group 7. And then that means that we'd need 3 bromines to balance out the chromium. CrBr3 would be the answer. So then you would just select the correct answer from down here. All right, so that gives you an idea of what you need to do. Does anybody have any questions? Does anybody have any questions? All right, well, then I guess I'll leave it here and wish you good luck. And for anybody else who's watching this later on, make sure you don't leave this till the last minute. And I do thank you guys for attending. Thank you. All right, well, have a good day.
Thank you.